Number 10. You're given a function f of x is x plus 1, and g of x is x squared minus x. We want to find the following things using those functions. So first off, let's find f plus g of 3. So to find that, that's the same as saying f of 3 plus g of 3. So I'm going to plug 3 into both these functions, and then I'm going to add them together. So f of 3 would be 3 plus 1, which is 4. G of 3 would be 3 squared minus 3. Would be 9 minus 3, which is 6. So 4 plus 6 is 10. Cool. Next one they want to know is f minus g of negative 3. Throwing some negatives in here. So f of negative 3 minus g of negative 3. That's what that's asking. It's basically asking you to plug negative 3 into both of these functions and then subtract those two values from it in this order. So f of negative 3 would be negative 3 plus 1. Would be negative 2. Minus. Now whatever answer I get here, I'm going to subtract it. So I'm going to put parentheses around it. Kind of keeps my negatives straight. So negative 3 squared minus negative 3. So look what happens here. We're going to add those. And then when I square negative 3, it's going to be a 9. So it'll be 9 plus 3. And 9 plus 3 is 12. So negative 2 minus 12 would be negative 14. All right, what's the next one they want? G minus f of 7. Yep, of 7, just a positive 7. Okay, so we're going to plug 7 into both of these and then subtract in this order. So we're going to find g of 7 and then subtract it from f of 7. And now notice, this is the way the function notation works, by the way. I'm not distributing a 7. That's not how that works. I'm just pulling it apart and rewriting it as two separate functions. All right, don't get confused. Don't think that I'm distributing. I'm not doing that. Okay. So g of 7, that's 7 squared minus 7, which would be 49 minus 7, which is 42, minus, so I might as well put that in parentheses, 7 plus 1, which is 8. So 42 minus 8 would be 34. All right, next one, it asks for domain. All right, find the domain of f over g of x. This is like saying f of x over g of x. Now, individually, the domain of f of x is all real numbers, right? You can add 1 to anything. Individually, g of x has the domain of all real numbers. You can square any value, and you can take that. You can subtract x away from any value. So what the problem is then when you start dividing them? Remember, the big thing you can't do is you can't divide by 0. So what value of x when you plug it into g, just like I did over here, I plug values into g, what value when you plug it in would give you 0 for the denominator? So basically, to find the domain of this, since it's a fraction, take the denominator, which is g of x, which is x squared minus x. You set that equal to 0. When you solve this, these are the values that cannot be in the denominator, in the domain. Okay, so if I solve this, I can solve it by factoring real quickly. Now set your factors equal to 0. So x can't be 0, right? If you plug a 0 in here, 0 squared minus 0 gives you 0. And that would give you a 0 in the denominator. So you don't want 0 in your domain. And if you solve this real quick, 1. What happens when you plug a 1 into g? 1 squared is 1, minus 1 is 0. You don't want a 0 in the denominator, so you got to get 1 out of that denominator, out of that domain. So how would you write that? You want to write all real numbers is like this, right? We want to basically carve out the 0 and the 1. So you start with negative infinity, go to 0. 0 would be the first value you would hit moving left to right, right? It's the lowest number, so we hit that. put a U, parentheses, and a 0. That gets rid of the 0 in that domain. Then you would go, and you would, next number you come to would be a 1. Put a union and a 1. Now that gets rid of the 1. By doing that, I stopped at 1, and then I picked back up at 1. And then I keep on going out to positive infinity. So that's the domain in interval notation if you're going to skip 2 values. Part E, same question, but it's been flipped around. So find the domain of g over f of x. So that's like saying g of x over f of x. All right, so what values give you 0 for f of x? Well, f of x is x plus 1. So what value gives you 0? Negative 1 does. So that's the domain cannot have a negative 1 in it, because if you plug a negative 1 in, you're going to get a 0 for the bottom, and you don't want to divide by 0. So your domain here would be negative infinity to negative 1, union, negative 1 to infinity. That gets rid of the negative 1 in the domain.